Hello, welcome to another lesson. In this lesson we're going to be doing some word problems, and it's going to involve algebraic fractions, but we're going to find pretty quickly that this is actually not a really difficult topic. So I hope that you find the same. It says in the beginning here, work problems, and work being like the physical idea of doing work, kind of a physics idea, often asks us to calculate how long it'll take different people working at different speeds, also known as different rates, to finish a task. The amount of work done, W, is the product, or the multiplication, of the rate of work and the time spent working. And the formula has three versions. The most important version we're going to take is we're going to be dealing with rates. And how this formula breaks down is as follows. The work on top, this W is the work done, and we'll see quickly that it's going to be talking about, for example, maybe you've got one tank filled. So maybe you're trying to fill like propane tanks or something, or maybe you're doing tests, so like 10 tests done. Maybe you're testing some water quality or something. It's the amount of things that you've managed to do. And the bottom, this time, is literally the time it takes someone or some group of people to complete something. And that's going to be usually in hours. And I might be talking kind of Greek to you now, so I want you just to see how these problems are put together by doing some examples. And it says here, some work problems have multiple machines or people working on a project together for the same amount of time but at different rates. So maybe someone really experienced with computers can do a job in 1 hour and someone less experienced can do the job in 2 hours, I don't know. But there's different rates involved. And it says here, and this is probably the most important sentence, in the case where we have different rates, we can add their individual work rates together to get a total work rate. And again, this is kind of gibberish until we see a problem. So let's see the problem. First of all, the big equation we're going to be thinking about all the time is work over time. Work over time. That's an old joke I used to tell in my physics class. How do you become very powerful in an organization? Well, you got to work over time. Work overtime. It's the formula for power. Anyway, you'll see that in physics class, and you'll think of me. Power is work over time. Anyway, in this case, its rate is work over time. What are we going to do? Well, let's read the question. An experienced technician can assemble a device in 10 hours. That piece of information is important in itself. It means that one technician can assemble one device in 10 hours. The amount of work that they do is to assemble one device, and the amount of time taken is 10 hours. Now we're going to add an experienced technician. Let me make that purple. An inexperienced technician will take 15 hours to do the same job. So an inexperienced technician takes one device, takes them 15 hours. So I don't know what they're assembling, but it's pretty complicated. And now what's this going to equal to? It says how long will it take them to assemble the device if they work together. So in the end here, we're going to have one device, and we don't know how much time it's going to take them to do that. And so we're going to call that our time t. So I'm going to write down what that variable t is. Okay, I'm going to label it here. Let t equal the amount of time it will take if they both work together. So hopefully you can see the big picture here. We've got work divided by time. We've got the job, how many things we accomplished, divided by the time taken. And then how many things we accomplished, but divided by the time taken. And then how many things we accomplished, divided by the time taken. That's how all of these equations are going to be set up. And now what are we going to do? How do we solve this? We need to multiply by the LCD. So take some time to figure it out, but the LCD is going to be what? It's going to be 30, because that's the lowest common multiple of 10 and 15. Maybe I'll make that on the side. 10, 20, 30, 40, 15. What are the multiples of 15? We got 30, 45, 60. What's in common? You got a 30. That's why that comes out in the LCD. 30 is the lowest common multiple. What variable do we have? We have no t's, 1 t. So let's go ahead and put that in the LCD. And you multiply everything by that, right? The previous topic told us that we need to multiply the LCD by everything. And I don't mean top and bottom, I mean multiply by every term. So this is what we're going to get. I'm going to take what we had, 1 over 10, multiply that by the LCD. Then I've got 1 over 15. I'm going to multiply that by the LCD. I've got 1 over t. I'm going to multiply that by the LCD. And hopefully you can see where they all come from. I'm going to make those a slightly different color. Hopefully the colors aren't overwhelming you. That's not the intention. I'll just make it a slightly nicer blue. And now we start to play the cancel game. 30t divided by 10. That's 3t. 30t divided by 15. Well, the 30 and the 15 can simplify down to 2, so that's a 2t. And then we have 30t divided by t. The t is canceled, 30 remains. 1 times 30 is still 30. And now we've got a nice easy equation to solve, which looks like this. 5t equals 30. Divide both sides by 5. And you've got 6. So this is in hours. So what did we solve for? Let's remind ourselves. How long will it take them to assemble the device if they work together? Well, if the experienced guy can do it in 10 hours, and the inexperienced guy, or woman of course, can take 15 hours to do it, if they work together they're going to take 6 hours, which is less than both of them, which is nice. So I'll just finish the sentence here. So it'll take them 6 hours to assemble the device together, working together. Now, honestly, that is kind of all you need to do all these word problems. You really don't need much more, many more examples than that. That's probably enough for you to get through this, but I'm going to go through them anyway, just so you get the practice, okay? So the next question, 1 pump can fill a tank in 3 hours. So that's our first rate. Remember, your work over the time. So we have 1 over 3. Again, I said work over the time. The work is to fill 1 pump, and the time is 3 hours. What about the next one? A second pump can fill the same tank in 5 hours. So a second pump can fill the same tank in 5 hours. So 1 tank filled in 5 hours. How long would it take both pumps working together to fill the tank? Well, still 1 tank. How long is that going to take? And once again, the T in this case is both pumps working together. And my device here is fighting me, so things are looking a bit weird. That's why. Let me fix this. Okay, technology. We'll see. Let's see how far we get. Both pumps working together. So if you're having trouble with this, pause the video, see if that makes sense to you. The answer is going to be 1 hour, 1 7/8 hours, which I think, sorry, I should have calculated this out ahead of time, times 60. That's 1 hour, 52 minutes, and 30 seconds, technically. But we can just we'll keep it as the fraction just to make life easy. So what are we going to do? We're going to multiply by the LCD. And what's the LCD here? Hopefully you can see it is 15t. So LCD is 15t. And one way that you might want to look at this, maybe I can break it up for you. It still works with factors, okay? So you've got 3. That's a factor. I didn't see that in the other one. I have a 5. That's a factor I didn't see in the other situation. And I also have a t. So I'm still going to collect all the different factors that I see. And really it turns out that this lowest common denominator is 15t. So maybe if you're having trouble thinking of it as common multiples, maybe that will help you get there. So we multiply that by everything. So 1 over 3 times 15t. You could skip this step if you want to and just go straight to the answer. You can do it in your head, but not everyone is comfortable with that. 15t divided by 3 here, that's a 5. 15t divided by 5, that's a 3. 15t divided by t, the t's cancel in that case, so I have 5t, 3t, and 15. Group the left side, Divide both sides by 8. Time is 15/8 hours. So a bit of a weird way to represent time, don't you think? Like if someone says, how long are you going to take to fill the tank, and you tell them 15.8 hours, it's a little bit awkward. It's not helpful to most people who actually work doing this stuff. So it's a bit nicer to fix this up, okay? So if the time is 15/8 hours, 15/8 as a decimal is 1.875 hours, which is still, that's okay. Not the best way to represent it. What I would recommend you do, take that decimal piece, 0.875, and take 0.875, multiply it by 60. All right, this is hours. Multiply it by 60 because there's 60 minutes in an hour. Google's listening to me. I don't know if you just heard that, but my pocket just tried to answer the question for me. 0.875 times 60, sorry for making this so small here, is 52.5 minutes. And then half a minute is 30 seconds. So it's really 52 minutes and 30 seconds. So you don't need to write every little piece here. I'm just trying to help you write the answer in something that makes a bit of sense. So you can say 1 and 7/8 hours is okay. You can say time is 1 hour, 52.5 minutes. Or you can say time is 1 hour, 52 minutes, and 30 seconds. All of those are okay. Even this one here is okay. I just wanted to show you multiple ways of getting the same answer, okay? And if you want to do this conversion piece, just remember your conversion is times 60. Let's do the next one. And again, you can probably do all these yourself, so I recommend that you try this one first. Let me just get the answers up for you. And the answer here should be 10 hours. So if you want to try this question on your own, the answer is 10 hours. Let's read the question. A laboratory technician can perform 10 blood tests in 2.5 hours. So 10 tests over 2.5. As a reminder, this is a rate. It's work over time. Work is the number of things you manage to accomplish, and time is the amount of, well, time it took to get that work done. I should have kept the arrow like it was. Okay, let's do it for the next case as well. Working with an assistant, the same blood test can be performed in 2 hours. So that one's a little different. The same blood tests, so 10 of them, can be performed in 2 hours. Now, I recommend that you don't write this, okay? Don't write what I'm about to write. Most students would say, working with an assistant, the same blood test can be performed in 2 hours. So a lot of students would write that, and then say, how long would it take the assistant to perform the same 10 blood tests as working alone? So 10 over t. That's not right. You can't do that. The way that we need to set this up, you're not allowed to do it that way. What we're going to think about is that we have the lab tech first, and then you need to add the assistant on the same side of the equation, and then that's going to give us our situation where we have both. Let me go back and show you how this works. Previously, we have one pump, second pump, and then both. Okay? In the first question here, we had experienced technician, inexperienced technician, and then both. So that third fraction, the one on the right side of the equal sign, that's always supposed to be both. So we should have lab tech, then assistant, then both. Hopefully you see what I'm trying to get at here. What I'm trying to get at is you have the lab tech, 10 over 2.5. Both of them together is this second sentence. Working with an assistant, the same blood test can be performed in 2 hours. 10 blood tests, 2 hours. And then it's the assistant we want to know the information about. So you take your 10, and it's the assistant's rate of time, or time taken, that we really care about. And let me just color code this so it can make more sense to you. And there we go. Pause the video, see if you can make sense of why I did what I did. But kind of your cheat sheet idea is that when you combine them, you usually have them on the right side of the equation. Now that we have that, we can solve our problem. Once again, hopefully you can look at this and figure out the LCD. It's a bit of a weird one in this case. You have 2.5, you have t, and you have 2. So maybe pause the video, see if you can figure that one out. 2.5, t, and 2. What's it going to be? Technically, you could use 2.5, and it would work out. But for safety, we actually don't need the LCD. We can just get the common denominator. We can still call it the LCD just for the sake of consistency, but just be careful with this. Anyway, what I'll do is take the 2.5 that I see, and I'll see another number 2, and I'll take the t. All right? What that gives us, the LCD, what it works out to, 2.5 times 2 is 5, and then t. So let's multiply everything by 5t and see what happens, okay? I'll write out all the workings. This times 5t plus 10 over t times 5t. And now 10 over 2. 10 over 2, that's just 5. Multiply that by 5t. All right, so something interesting happened there. I probably should have simplified this first to get 5, and it would have been a whole lot easier. But anyway, I don't have any regrets. It is what it is. It all is going to work out the same way. So the first situation here, 10 times 5 divided by 2.5, that's 50 divided by 2.5, which gives 20, so that's 20t. If you missed that, 10 and 5 is 50, divided by 2.5 is 20. So just take some time, try to figure that one out. 10 times 5 is 50, and the t's cancel. So it's 50. 5 times 5 is 25, 25t. Now on the left side, it's all simplified. On the right side, same thing. I'll keep the 50 on the left. I'll move the 20 to the right, so it's 25t minus 20t. And then I should have 50 equals 5t, and divide both sides by 5. T will end up being 10. And what's my unit of time here? I believe it's 5 hours. 10 hours. Let's look back and see if it makes sense. Lab tech can perform it in 2.5 with an assistant. Wait a second. Yeah, okay. So this is the tricky part. I almost confused myself. Working with an assistant, the same blood test can be performed in 2 hours, but the problem is we didn't know how long it takes the assistant to perform the blood tests. So let's look back at the equation and see if it makes sense. The lab tech can do it in 2.5 hours. If they work together, they can do it in 2 hours. How quick is the assistant? Well, the assistant's pretty terrible, to be honest. It takes them 4 times as long to get this done. It takes them 10 hours when the lab tech takes 2.5 hours. And that makes sense. The assistant is not properly trained yet. That's why they're the assistant. So the answer actually does make sense. And hopefully, you can see what I'm getting at here. So the final question here, the practice, and you should really try this yourself. It is pretty much the same as you saw for the other ones. There's not like a big twist. Well, I guess there's a little twist. And the twist is that there's 3 people in this question, not 2. But at the end of the day, the question is set up the same way. So let's just pick the question apart and see where we can get. It says Jamie, Sarah, and Paul, 3 people, can paint a room together in 2 hours. And so together means that all of them together, all 3 of them, are going to be able to paint one room in 2 hours. And once again, for the last time, this is our work on top, how many things we've managed to accomplish, and then our time on bottom. And why do I set it up this way? It's because our rates. So I'm always dealing with my rates, which are work over time. Now, that's if they paint it all together. If Sarah works alone, she can paint the room in 5 hours. So Sarah over here is going to try to paint one room in 5 hours. Maybe they know that based on past experience. They have all this data somewhere at the job, and they know roughly on average how long it takes her. If Paul works alone, he can do it in 6 hours, so he's not quite as efficient as Sarah. Maybe he's a younger guy, maybe he just is new to the job, maybe he just doesn't know how to paint a room. Who knows? If Jamie works alone, how long does it take him? Apparently it takes him some mysterious amount of time to paint one room. Maybe we've got his data. Who knows? We don't know how long he takes. He's only worked with other people, and maybe we want to figure out how long it would take him based on previous experience. It doesn't really matter. What matters is that we have our 3 separate pieces on the left, and we have the final piece on the right where they all work together. And this matches kind of our previous setups, right? Everything checks out in terms of what we did before. Now I need to find that t. So you tell me, what is our common denominator? Well, I guess you can't tell me, can you? But you can pause the video and give it a shot. So we need to find the lowest common multiple between 5, 6, and 2. So if you're really, really stuck, just multiply everything by 5, 6, and 2. That would be perfectly fine, but maybe not the smartest approach. If you want to figure it out, think about 2's, 5, and 6's and figure out what the lowest common multiple is. So 5, 10, 15, 20, 25, 30. I have a really strong feeling it's going to be 30 here. 12, 18, 24, 30. Okay, we've got a match. 2, 4, 6, 8, 10, and so on. It's eventually going to be 30. 30 is our key number here by the looks of it. That's our lowest common multiple, also known as, lowest common multiple, which matches our lowest common denominator. So it's 30, which is 6 times 5, not 6 times 5 times 2. And then we've got our t. All right? Now, what are we going to do? We're going to multiply everything by that 30t. And if you figured out, if you did 5 times 6 times 2 and you got 60, it's still going to work out. Don't worry about it. Just multiply everything by that. So 1 over 5 times 30t plus 1 over 6 times 30t plus 1 over t times 30t. All right? And this is 1 over 2 times 30t. Don't forget to multiply that side as well by the denominator. And I'll just make it a little different color just to show you that I didn't have that to begin with. And play your cancel game. 30 by 5, that's a 6. 30 by 6 is a 5. 30 here, nothing cancels there. But 30 over 2, wait, I forgot a t here. That was close. I thought there was something weird about that not canceling. We've got 30t. That will cancel the t. That's a good thing. All the fractions need to cancel, right? And then on the right side, 30 over 2 is going to be 15. So let's see what we have. We have 6t plus 5t plus 30 equals 15t. Now, if I hadn't caught this, I know I made a little mistake on the t's here. If I hadn't caught that, I would have noticed that one of my fractions would not have canceled. I would have ended up with a fraction here, and I would have thought, okay, there's a problem, because the whole point of the LCD is to get rid of all the fractions, okay? So just kind of a fail-safe if you ever get into that situation. Group-like terms on the left and right. On the left side, I have 11t plus 30. On the right side, I have 15t. I'm going to save myself some effort and bring the t's to the right side. That'll keep me from having any negatives. You can keep it on the left if you want. It's no big deal. This is a 4t. I want to get to that t, so divide both sides by 4. That'll leave me with t only. And then the moment of truth, 30 divided by 4. What is it? It is 7.5. That's hours. So 7.5 hours, also known as 7 hours and 30 minutes, if you wanted to think of it that way. And that is how long it would take Jamie to paint the room. So it's a nice idea to go back to the beginning whenever you finish a question and see if it makes any sense. If it really doesn't seem right, then you should probably check your work again. 7.5 hours, is it realistic? Well, it's not like 20 hours, it's not 100 hours, it's not 0.002 hours. So it makes some sense. Let's take a look. Sarah takes 5 hours, Paul takes 6 hours, Jamie takes 7.5 hours. So what I would say is that Sarah and Paul are fairly experienced, and Jamie not quite as experienced. He takes a little longer, 7.5 hours. But that's okay. When they all work together, it takes them 2 hours, so it all works out in the end. All right, that is the end of this video. That's the end of this topic, and in fact, it's the end of the notes in general. So we've finished Unit 6 now. I hope that you can figure all the topics out. I hope it's not too overwhelming. If you go to D2L, so this is what it looks like, at least for this time. Course Home, go to Content, and go down to Unit 6, and then go all the way down to the bottom. You're going to see some extra practice for Unit 6. So you click on that, and then I recommend you give these a shot. In fact, I already brought this up in a previous class, but this is good practice. Factoring, simplifying, operations, so plus, minus, multiply, divide, and then solving. That's in a previous lesson. We did the solutions. How do we know it's solving? It's because we see this equal sign. Oops, it's hard to just get the equals. This equals, it means you solve it. And then the answers are there. Now you'll notice that this topic, this final topic, we don't have any extra practice on, but it's pretty straightforward. So what I'd recommend you do if you're having trouble remembering how to do it, just cover up all the answers and try it from scratch. And then I think there's a question on the assignment like this, so that would be some good practice too. That's it for the video, and once again, that's it for the unit. I hope you have a great day, and we'll see you in the next lesson.